G'day again. So this time we're going to do revision. This is the Year 10 June revision, and we're going to start with simultaneous equations. So we're going to do five topics. Here we go. So first of all, let's graph the solution to this. So it says graph the solution to this simultaneous equation. You don't have to solve it algebraically. You just have to put that there, and that's it. You're done. So these are pretty simple. These are both lines. So y equals mx plus b. Y equals mx plus b. B is your y-intercept, so let's put that on there. Let's put a 1 right there, put a dot. This is our gradient, rise over run. So any whole number is a number over 1. So 2 over 1, so we're going to rise 2, run 1. So that's 2 over 1. So rise 2, run 1. So from our dot, rise 2, 1, 2, run 1. Put a dot. Make sure it's over the top of the 1. And that's it, that's our line. We can join those together. And there's our line. Done. So since you've got two lines, very handy to label the lines. So we've got y equals 2x plus 1. So up here I would write y equals 2x plus 1. Somewhere connecting so the examiner knows, you know that line is that. Don't leave it for granted that the examiner knows, oh yeah, they know what they're talking about. Make sure you label it. You could label that and say, well, that's A, and put an A on it and say, well, that's my line A. So somehow you've got to let the examiner know that you know this is this. Okay? Good to remember. Next one, y equals minus 2x plus 3. So again, plus 3 is our y-intercept. So put a dot on 3. Gradient, rise over run. So a whole number is a number over 1. So rise minus 2, run 1. So we're going to rise minus 2, we're going to go down minus 2. So go down minus 2, or so go down 2, 1, 2, across 1, put a dot. Join the dots. And again, mark it somewhere, either there or there, to say this line, you acknowledge that this line is that one you've drawn. So we'll just do it down there, y equals minus 2x plus 3, and now we'll go make it a b, that's b. So you don't have to do a and b, but yeah, as long as it's clear to the examiner. You don't have to mark that point, you just have to make it clear where that line's going, and it's obvious to the examiner, yes, you've drawn it correctly. Let's extend it and do another question. So let's say that was the first question, was draw that, so you've drawn it correctly. Let's change the question a little bit and say graph the solution to, and we'll just change this, so we'll leave the questions alone. Graph the solution to that, and we change that to look like that. You do exactly the same first step. So you map your lines exactly. You don't have to mark the lines. That's not really important. So now we don't have to do this. You graph your lines. The difference is in here. So this is a greater than sign. This is a greater than or equal to sign. For this sign, we want dots. For this one, we want a solid line. Okay, that's the difference. So let's change this one, y equals 2x plus 1, which we know is this line, okay, into dots. So I can do it by rubbing it out, a bit easy, by just putting dots there. So now that's a dotted line. Okay, the dotted line means it doesn't include that. This is equal to, so it's a solid line. Okay, so next step, put in a point that's not on the line. So let's do this one and test it. So we're going to test this one. So here's our test. And I like putting in 0, 0 because it wipes everything out. You don't have to do too much thinking. So we're going to put a 0 there. 2 times 0 is 0. So we're going to get 0 is less than 0 plus 1. Is that true or false? So is 0 less than 1? Yes, it's true. So if that's true, that means for this line, everything on the 0, 0 side of the line is true. Okay, so there's 0, 0. Here's our line, this is the dotted line. We're looking at the dotted line. So everything on this side of the dotted line is true. So we want there, this is all true. Okay, that's your first step. Let's do the next one. And again, we just test it. The only problem with testing is you've got to make sure that 0, 0 is not on the line, that it doesn't actually go through 0. So again, this line doesn't pass through 0, so put in 0. So 0, this is a 0, and we've got 3. So 0 is greater than or equal to 0 plus 3. This is my test. Is that true or false? Is 0 bigger than or equal to 3? No chance. 0 is definitely not bigger than 3, so that's false. So for this line, which is our solid line, 0, 0 is false, so we don't colour in 0. So this side here, for this line, is false. So we're going to colour in that side of the line. So we want that. So the answer to the question is, what is graph the solution to this and this? We want where it's both true. So our answer is here, is in that section there, because it's crossing over both of them. Not here, and not here. This is our answer. So you would colour that in more heavily for the examiner. So you put extra lines there and say, well, this is my answer. Mr. Examiner, please look at this and don't look at the other stuff. This is what I want you to look at, this stuff here. And by putting the extra lines in, you're telling the examiner, you've done your check, but this is your answer. So you can write, solution is this stuff. Like that, and you're done. G'day again. So back for a little bit more of simultaneous equations. Another question you're going to get is solve by calculation. So I've used the same equations and it's pretty easy to solve for this example. So you can either add them together, because if you add these two, it'll wipe out your x's, or you could subtract them, because if you subtract these two, it'll wipe out your y's, or you could just make this equal to this, because you've got y equals this and y equals this. That will find out your x and then put it back in to find your y. So either way, either of those three ways will solve it. So we'll just add them together for this one. So let's go. We've just got a big plus sign. 1 plus 3 is 4. 2 plus minus 2 is nothing. Y plus y is 2y. 2y is 4, so therefore y equals 2. So that's our first solution. And we can put that either there or there. Now let's put it up the top. So y equals 2, so I'm just going to put a 2 there. So 2 equals 2 times x plus 1. So 2 equals 2 plus 1, well 2 equals 1 plus 1. So if this is 1, so I'll take the 1 off this side. So 1 equals 2x, divide by 2, so a half equals x. And that's our solution, y equals 2 and x equals a half. And you're done. G'day again, back for one more simultaneous equation. We're going to solve by calculation. It could say solve algebraically, that's another way they could say that. So either way, as soon as you see that word solve, you're doing some algebra or algebraic manipulation. If you get a question like this where this is not in the same form as this, I think it's quite easy to just change them into the same form so that they're both easy to subtract. We can easily do that by moving this across here and having two equations. So let's change the top one down here to say y minus 3x minus 1 equals 0, and now we've got them lined up together. And you can subtract or add. Well, you can't do either at the moment. We'd need to double this one. So let's double it. So 2, make that a 6, and make that a 2. Now we can subtract, because that'll wipe out our y's. So that's one way to go about it. Let's finish that now, since we've started on it. 2 take away 2 is 0. 4 minus minus 6 is 10x. Minus 2 minus minus is a plus. So then we've got 2, minus 2 plus 2 is 0. 10x equals 0. So what's x? X equals 0. And that makes life really easy when we substitute anything back in. Put that back in there. So therefore y equals 0 plus 1. So y equals 1. So a very easy solution in this case, maybe not so easy if you don't get it. This is often confusing. If you get 10x equals 0, often students go, oh my goodness, I've got a 0. That can't be right because how can I put a 0 back in there? Well, that's the answer. The answer can be a 0 and a 1 because on the graph, let's remember, these are both lines on a graph. They could pass over where x is 0. So this is 0, 1. So let's just draw a really quick graph that we can actually see. So 0, 1 is here. So what this solution is telling us is that these lines, these two lines, cross over here, there, and that's the solution. So getting a 0 is not always a bad thing, and you're done.